Hello everyone, today we are going to learn about light. We all are familiar with light. However, light is a very vast topic to learn about because it has many properties like intensity, propagation, frequency or wavelength, polarization, speed, etc. Among these, the interesting property of light is speed, because the speed of light is about 3 lakh km per second. That means in every 1 second, light travels a distance of 3 lakh kilometers. 3 lakh kilometers is a huge distance. Do you know what is the circumference of the earth? The circumference of the earth is just 40,000 kilometers. Now imagine you have a car outside your home. The maximum speed of this car is 3 lakh kilometers per second. Now you sit in this car and start driving it. Do you know how much distance you will travel in 1 second? You will go around the earth 7.5 times in just 1 second if your car travels at speed of light. That is why the speed of the light is one of the most interesting properties. However, about all these properties of light you will learn in higher standards. Today what we are going to learn is reflection and refraction of light. The syllabus that we will cover today is based on CBSE textbook. It is the 10th chapter of science in CBSE textbook. What is the basic definition of light? Light is nothing but a form of energy. Just like we have sound, a form of energy, heat, another form of energy, electricity, one more form of energy. Similarly, light is also a form of energy. From where do we get this energy? We get the light energy from electric bulb, electric tube light, halogen bulbs, LED, etc. There are so many examples. In fact, the screen what you are watching is also producing a light. It's also a source of energy. But what about olden days when there was no electricity? What was the primary source of light? In fact, what is the primary source of light? Obviously, it is the sun. The sun is a very important source of light energy. Without the energy from the sun, there will be no plants or animals on the earth's surface. We know and we have learned in our lower grades that plants and animals need light to live. Now, what we are going to learn about light in this chapter? We are going to learn how light makes things visible. Also, how we can see far away objects near to us. The best example is telescope. With the help of telescope, we can see far away stars very close to us, far away planet close to us. Let us start with how we can see the things, or how light makes things visible. An object reflects the light that falls on it. The reflected light, when received by our eyes, enable us to see the things. These are the examples. The light from the sun falls on the apple, and then apple reflects the light, and this reflected light is received by our eyes, and we are able to see the apple. And this is true for all the objects. Now just imagine the light from the sun falls on apple, but the reflected light from the apple never received in our eyes. So can we see the apple? Obviously no. The important thing is that when the light is reflected from the apple, it should be received in our eyes. Then only we can see the things. Let us take a practical example. Now we are sitting in one room, and in other room there are many things, maybe chair, sofa, bed, etc. Now you are sitting in this room, and in that room the light is on, but still are you able to see those objects from here? No. Why you are not seeing this? Because the light from the light source, maybe tube light, falls on that object, but it is not reflected to your eyes. It is being obstructed by walls in between. That is why you are not able to see the object that side. Just imagine if this wall is made of a glass, that means this wall is transparent. Okay, then will you be able to see the objects in the other room? Obviously yes. the light falls on those objects, then it got reflected from there, then it passes through this wall, or we can see the glass or the things, and then it will be received in your eyes. Then you're able to see those objects. That means we can see the object only through the transparent things. In fact, what is the definition of transparent things or opaque things? Transparent things are those through which we can see, and opaque things are those through which we cannot see. This definition we have learned in lower grades. Now it's time to redefine the definitions. What are the transparent things? Transparent things are those through which light can pass, so that the objects on the other side of the transparent things are visible. Because light reflected from the objects can pass through the transparent things and can be received in our eyes, and we can see the object. Whereas for opaque, the light cannot pass through them. The object on the other side reflects the light, but the light is obstructed by the opaque object, and that is why we cannot see the object on the other side of a opaque thing. So things through which light can pass are transparent, and things through which light cannot pass are opaque. And that's the reason we are able to see through a transparent medium, as light is transmitted through it. Now let us go through the introduction of this chapter. We see a variety of objects in the world around us. However, we are unable to see anything in the dark room. On lighting up the room, things become visible. What makes things visible? The answer is obviously the reflected light from the things. The reflected light from the things is received in our eyes, and we can see the things. During the day, the sunlight helps us to see the object. An object reflects the light that falls on it. The reflected light, when received by our eyes, enable us to see the things. We are able to see the things through a transparent medium, as light is transmitted through it. There are a number of common wonderful phenomena associated with light, such as image formation by mirrors, the twinkling of stars, the beautiful colors of rainbow, bending of lights by a medium, and so on. Here, what you mean by phenomena? Phenomena are nothing but the facts that are easily visible and no one can deny it. So what are the wonderful phenomena associated with the light? They are the image formed by a mirror, the twinkling of stars, beautiful colors of rainbow, bending of light by a medium, and so on. Among all this phenomenon, the phenomenon of formation of image in the mirror is due to reflection and refraction of light, and that is what we are going to learn in details. Twinkling of stars, again we see the stars twinkling. Why? Because the sunlight is reflected by stars, and that's the reason we see the twinkling of stars. However, beautiful color of rainbow and the bending of light by medium are the phenomena which we will learn in higher grades. We see a rainbow because the sunlight falls on the water droplet, and the water droplet separates the light into different wavelengths, and based on the wavelengths different colors are formed, and all these colors are nothing but the colors of rainbow. So all these things you will learn in higher grades. A study of properties of light helps us to explore them. By observing the common optical phenomenon around us, we may conclude that light seems to travel in a straight line. This is very important. The thing is that light seems to travel in a straight line, and we can say this by observing the common phenomenon around us. And what is this common phenomenon around us? The fact that a small source of light casts a sharp shadow of an opaque object points to this, the straight line path of light, usually indicated as a ray of light. So when there is a small source of light and there is any opaque object, we can see a sharp shadow around it, and this shadow will be created only if the light travels in a straight line. And this is also true for the source of light which are very far away. For example, sun. We know that the sun is far away from the earth, and the size of the sun is more than the size of the earth. But still, what we see, the shadow created by suns are very sharp. So the thing is that either the source of light should be at a very far distance, or should be very small if it is close. Then only it will create a sharp shadow. And most important, sharp shadow is created when light travels in a straight path. So we get sharp shadow in two conditions. First, the light should travel in the straight line, and second condition, the source of light should be far away or it should be small. The conditions that make blur shadows are: first, the light should not travel in a straight line, and second, the source of light is very close or the source of light is very large. You will learn in higher standards that why blur shadows and sharp shadows are created because of these conditions. This chapter of CBSE is limited to the study of the phenomenon of reflection and refraction of light using straight line propagation of light. These basic concepts will help us in study of some of the optical phenomena in nature. We shall try to understand in this chapter the reflection of light by spherical mirror and refraction of light and their application in real life situation. So this is the only thing that we are going to study in this chapter, that is reflection of light, refraction of light and straight line propagation of light. That means reflection and refraction of light, but assuming that light is traveling in a straight line. Now what is the difference between the reflection and refraction? Here are the example. The first example is for reflection. Light from the light source falls on any object and then it bounces off, and this is what we called as reflection of light. What about refraction? What is refraction? When light passes from one medium to another medium, it tends to bend at a point between the two medium. In this example, we have a tub filled with water. Now tell me which are the two mediums. The first medium is air and second medium is water, and the light is traveling from air to water. Now let us insert a pencil into this tub of water. What you will see? You will see that the pencil seems to be bent at a point where air and water meets. This bend of a pencil is due to refraction of light. The pencil actually it is straight, but it is looking or it seems to be bent because of refraction of light. So refraction of light means that the light bends when it travels from one medium to another medium, and it bends at a point where these two medium meets each other. Now let us learn the topic 10.1, that is reflection of light. Let us start 10.1, reflection of light. A highly polished surface such as mirrors reflect most of the light. In this sentence, what is mentioned is that highly polished surface reflects most of the light, which means that all the lights that falls on an object is not reflected. Some of the light is absorbed by the material and portion of the light is reflected, but always there is some portion of light which is absorbed by all the materials. In this sentence, they have also emphasized on a highly polished surface like mirror. What you mean by highly polished surface like mirror? Let us understand. You can see a clear image of yourself in a mirror, but you cannot see clear image on other surfaces which are not so polished. Why this happen? Because the reflected ray of highly polished surface are all parallel, and that helps to form a clear image. Whereas on a rough surface like some steel utensil or any other thing, the reflected ray are all scattered. They are not parallel, and that is why they form a blur image. You can see in these examples, on the left side, the highly polished surface reflects the light rays parallel to each other, so the image formed is clear. Whereas on the other side, on a rough surface, the reflected rays are scattered, and that is why they do not form a clear image. They form a blur image. After introduction to this chapter, this is the first sentence of a science textbook, and all this explanation is just for the first sentence. That is, a highly polished surface such as mirror reflect most of the light falling on it. So now you can realize that how important is each and every word and sentence of your science textbook. If you fail to understand meaning of any of this sentence or word of a science textbook, you will find the light chapter very difficult. The conclusion of this sentence is that objects does not reflect all the lights that falls on them. Some portion of the light is absorbed by them, and a highly polished surface forms a clear image because they reflect parallel light rays. You are familiar with the laws of reflection of light. So what are the laws of reflection of light? Let us recall. The angle of incidence is equal to angle of reflection. So the first law is angle of incident is equal to angle of reflection, and we expect that you already know this. Second, the incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. That means three rays, they lie on the same plane. That is, first the incident, the normal, and the inflected. All these three lines lie in the same plane. If you have forgot what is incident ray, what is normal, and what is reflected ray, let us learn it once again. See in this example, this is a polished surface. This red color line is incident ray. It is coming from the source of light. This blue color line is reflected ray. It is getting reflected from the polished surface. Now what is normal? Normal is nothing but a line in between incident ray and the reflected ray. It is called normal because it is normal, that is, it is perpendicular to the polished surface. So this black color line is normal. Now let us see what is angle of incident. The angle formed by the incident ray to the normal is called angle of incident. The angle formed by reflected ray to the normal is angle of reflection. Angle of incident is denoted by I. Angle of reflection is denoted by R. As per the first law, the angle of incident is equal to angle of reflection, that is, I is equal to R. And you can see that all these three lines, that is incident ray, reflected ray, and normal, they lie in the same plane. In our case, this is this yellow plane. So all these three lines are in the same plane, and this is as per the second law, that is the incident ray, the reflected ray, and the normal lies in the same plane. These laws of reflection is applicable to all types of reflecting surfaces, including the spherical mirrors. And spherical mirrors we will learn in detail in this chapter. What about the properties of image formed by a plane mirror? Image formed by a plane mirror is always virtual and erect. Now let us understand the meaning of virtual. In general, meaning of virtual is something which is not real. Now let us understand the meaning of virtual in terms of light. In terms of light, real image is created when the reflected light originates from the objects. If the reflected light is not originating from the object, then the image created is not real, it is virtual. Later in this chapter, while learning about the ray diagrams, we will see the conditions when the reflected rays are coming or originated from the mirrors, and when the reflected ray are not originated or not coming from the mirrors. They normally originate behind the mirrors or from the backside of the mirrors. So such images are called as virtual images. The sentence says the image formed by plane mirror are virtual and erect. Now we have seen what is virtual and real images. Now what about erect? What do you mean by erect? Erect means straight. What is opposite of erect is inverted. That means what you can see if you are standing in front of a plane mirror, you can see your head aligned with your head. It is not inverted. That means your head is not aligned with your toe and your toe is not aligned with your head. That means the image is not upside down. There are conditions where image is inverted. That means it is upside down. Again, we will see this when we are learning the ray diagram. The ray diagrams are very important and we need to learn and need to draw the ray diagrams in this chapter. This was the first property of the image formed by a plane mirror. That is, image formed by a plane mirror is always virtual and erect. Second property, the size of the image is equal to size of the object. This is very simple to understand. That is, the size of the image is exactly same as the size of object. Obviously, in concave and convex mirror, that are spherical mirrors which we will learn in this chapter, the size of the image is not same as the size of the object. It may be either enlarged or it may be reduced. Third property of image formed in a plane mirror. The image is formed as far behind the mirror as the object in front of it. This is very simple. When you stand in front of mirror, the distance between yourself and the mirror is same as the distance between the mirror and your image formed in the mirror. Next, fourth property. The image is laterally inverted. What do you mean by it is laterally inverted? When you stand in front of mirror, your right hand seems to be your left and your left hand seems to be your right. That means the image is inverted from right side to the left side and vice versa, left side to the right side. So all these are the four properties of the image formed in a plane mirror. In this chapter we are going to learn about curved mirror. Curved mirror, especially here are the spherical mirrors. We have to learn how the image would be if you see in the spherical mirror. Before learning about spherical mirrors, it is very important to do an activity. This activity is very important to understand the theoretical concept of the spherical mirror. If you don't take this activity seriously, you will find it really difficult to understand the following concept of spherical mirrors. This is a very simple activity. Let us see what you have to do. First, take a large shining spoon. Try to view your face in the curved surface. That means you have to view your face inside of the spoon. Do you get the image? Obviously you will get the image of your face. Is it smaller or larger? This you have to tell me whether it is small or large in the comment section. Next, what you have to do? Move the spoon slowly away from your face. Observe the image. How does it change? So when you move the spoon away from your face, the image of your face will change. Maybe it will become small or maybe it will become big. Maybe it will be erect or it will be inverted. So you have to tell me how does it change. Next, what you have to do? Reverse the spoon and repeat the activity. That means initially you are looking inside the spoon. Now turn the spoon and look outside the spoon. Tell me how does the image look now. Last, compare the characteristic of images on the two sides of the spoon. So this activity is very simple and you need to perform it seriously just to understand how spherical mirrors create images. To give you more interest in this activity, I will just share an image with you. See this interesting image. When you see inside a shining spoon, your image will be upside down. It is inverted. It is not erect. Whereas you see Outside of the spoon, the image is erect. So try this and let me know. Here we will end our first session of chapter Light. Subscribe the channel and click the bell icon to get notified when the second session of chapter Light is uploaded.